Welcome to Where Parents Talk. My name is Lianne Castelino. Our guest today is a professor of mathematics at the University of Winnipeg. Dr. Anna Stokke has a PhD in mathematics and is an advocate for math literacy in children. She is also president of a nonprofit organization that teaches math to children, and she's a mother of two. Dr. Stokke joins us today from Winnipeg. Thank you so much for taking the time.
Well, thank you so much for having me. I'm happy to be here.
Certainly a subject that has preoccupied the minds of many educators, students, and parents for quite some time. I wonder, what is your assessment of where we are currently in Canada, generally, when we talk about outcomes for students in mathematics?
Sure. Well, I'd say a couple of things. So I'd say I think too many of our students get left behind early on in math. And what I mean by that is too many students don't actually reach baseline numeracy levels that would allow them to continue on in math, that would give them access to careers that rely on math, like STEM careers or economics, that sort of thing. And I would also say that at the high end, we don't have as many high flyers as we used to, looking at past testing, like when you look at the trend over time with tests like PISA, that sort of thing. So I think we have too many students that are struggling in math and not enough students that are reaching the highest levels in math.
So when we look at the first point you made, what would you attribute to the erosion of foundational skills, and what age is this starting?
Oh, sure. Okay. So I think there are a lot of things that contribute to that. So something to keep in mind with math is it's really cumulative. So everything builds off what came before. So it can be really easy to get behind in math, and you can get behind very early on. So I think just there's been a shift in the way math has taught over the last several years. So we saw pretty big curriculum changes in around 2006, but it's not just the curriculum, it's sort of the methods that are being used in schools, the methods that are commonly promoted among people that, are math educators that get hired to do professional development, that sort of thing. Not enough focus on making sure that kids have like really good basic math skills, and kids need a lot of practice to get good at math. And we're not always seeing enough of that. So I think those are some of the things that I could just sort of say in a nutshell.
And so when you meet students who are struggling, typically what age are they? And is there a trend in what they're coming to see you for?
Okay, so you're talking about at my nonprofit then.
Mm-hmm.
Okay, so that is grades 4, 5, and 6. We've also done 7 to 10 in the past. We just sort of concentrate on 4, 5, 6. So we have a wide range of kids in the program. Some are there because they want more challenge, right? So we do provide enrichment problems, and some kids are there because they're struggling and they need to get more foundational skills. And the reason we did concentrate on 4, 5, 6 is because those early grades are really important. Like, it's where the foundation gets laid so that kids can be set up for success in algebra later on. So I'd say they come in, if they're struggling, it's things like there hasn't been enough emphasis on memorizing times tables. There hasn't been enough emphasis on things like, just basic arithmetic, right? Those kinds of things. So that's sort of the thing that we really try to focus on. But then we do have like a lot of enrichment problems. Like, we do math contest problems with the kids because there are kids that actually do need extra challenge and they're not getting that in school as well.
So for parents with children in those age groups, as an example, listening to this interview or watching it, what would be your advice to them to be proactive, knowing that it's taught a certain way currently in the curriculum in different schools versus tried and true traditional methods, like you mentioned, memorization, et cetera? What would you be saying to those parents?
Okay, I'll say a few things. So you can the idea is you want your children to be at a spot where they can succeed in algebra. Because if they can't do algebra, basically that's going to cut off a lot of math for them later on. Okay, so you can trace that back. So in order to do algebra, you have to be good at fractions. You have to be able to add and subtract and multiply and divide fractions, right? And you have to be able to do this fluently, not with pictures, actually fluently, like with pencil and paper. And to do that, you have to be able to add and subtract, multiply and divide whole numbers and work with integers, right? So first of all, I always say to parents, number one, make sure your child memorizes their times tables. If what's happening at school isn't allowing that to happen, you have to do it at home. And there's lots of ways you can do it. You can use flashcards. Flashcards are great. There's free programs out there like factfreaks.com. And then I would say pick up something like Jump Math and do that at home with your child. Those are really good workbooks. Just make sure they get a really good foundation in basic arithmetic, really, and fractions. So those are the main things I would concentrate on.
We're talking about the parents there, but how about policymakers and educators who, educators deal with this on the front lines every single day, maybe some of them having to teach a curriculum that they don't fully support. What would you say to educators about how to instill some of those fundamentals in math?
Okay, so sure. So the first thing is, become informed. So I would say, and I have a podcast, so you could, for instance, listen to a couple of those episodes. One thing that's really helpful is the IES practice guide for assisting students struggling with math. That's IES, I think it's Institute of Educational Sciences, and it lists like 5 things that have been shown to their evidence-based approaches for helping kids with math. And one of those things is systematic explicit instruction, like systematically, explicitly teaching kids how to do things, like modeling how to do something and then getting the kids to practice that on their own and then getting lots of practice and giving the kids lots of feedback. So I would say the most important thing is to inform yourself about what evidence actually says about the best ways to teach young children math, because a lot of the stuff you hear out there actually isn't evidence-based. People will tell you it's evidence-based and they're happy to sell you their programs, but is it? Right? So I have an episode called Red Flags in Education Research, where we went through 5 red flags to look for when someone tells you that something's research-based. And that might be really helpful. For policymakers, personally, I don't think that we should be funding programs in schools that aren't backed by research. And if someone says that their program is going to help children learn math, they should be able to provide evidence of that. Is it going to improve math outcomes? Because if not, why are we paying for it? Why are we sending teachers to all sorts of professional development for programs that haven't been shown to work? And sometimes use methods that in fact go against what research tells us should help students learn math. So those are some of the things I would say.
So when you look at the landscape currently, I guess, what strikes you most? What concerns you most about what we're seeing, the trends that we've been seeing for many years now in Canada, certainly when you talk about PISA and other global testing, what concerns you most?
Oh, sure. Okay. So, well, first of all, math is really important. Okay, so math is probably more important now than it ever was, right? So it basically underpins so many important careers that are important for our economy. So for instance, careers in technology, all the STEM careers, you hear a lot about data science. You have to have a really good foundation in math. You even have to be able to take calculus to become a data scientist, and economics and frankly, a lot of the trades as well. And so that is really concerning, right? If we have many students struggling in math, or if they're not being given opportunities, like we owe it to children to make sure that they get a good foundation in mathematics so that these opportunities are open to them. So those things really concern me. And I think that math really does need to be emphasized in schools. Like, we hear a lot about reading, and reading is really important. And there are still some ineffective methods being used to teach reading, but people are talking about it, and people seem to know that there are these effective ways to teach reading that haven't necessarily always been used. And sometimes, we find out now that a lot of states and provinces are now saying you have to use effective methods to teach reading. Children have a right to learn how to read, but we don't hear the same conversation when it comes to math. Like, we're quite far behind reading when it comes to math. And so those things concern me a lot. And I hope that, we can turn this around, and that people do start recognizing that math is important, and children can learn math, right? They just need to be taught well.
That was going to be one of my questions for you, which is, a lot of people will say, well, you know what? My son or my daughter doesn't have a math brain. They're just not wired to understand this, et cetera, already putting that child behind the 8 ball in terms of their confidence. What would you say to that parent or that student about how to overcome that?
Okay. So that's a place where it's quite different in math than it is in reading. And I think that most people will say that everyone can learn to read, right? But then we have this thing that happens in math where people will say, well, I'm a math person, and this other person's not a math person, or, I never was good at math, so why would my kid be good at math, right? I think everybody can learn math to a certain level anyway. I mean, we should all be able to learn algebra and be in a position where we could take an academic stream of math in high school. But I think that it gives people almost an excuse not to worry about it as much, and that as a result, kids don't necessarily have adults advocating for them. Because they think, well, this is just the way it's going to be. But it's not, right? I mean, if you get good instruction, if you get a good foundation in math, you can learn math. But some people do need a lot more practice than others. That's true, right? And some people things do come more naturally to them. But I always say, at the end of the day, so a good example is times tables, right? So it takes some people not very long to memorize their times tables. And then it takes other kids a really long time to memorize their times tables. But when those two kids have memorized their times tables, even though it took one longer than the other, now they're the same. You can't even tell, right? So the point is, as long as you get enough practice and the amount of practice you need, you should be able to get to the same point.
You are based in Winnipeg, and you have written about what's going on in your home province of Manitoba. What would you like to see happen both in the short and the long term to address the downward trend when it comes to math outcomes?
Sure. So I've written about Manitoba. I've also I wrote a C.D. Howe intelligence memo that was sent to all ministers of education across Canada. So I had sort of generic methods or generic recommendations for that, and then I've written specifically for Manitoba in my local paper. So some of the things I would say, well, first of all, and I mentioned this already, I think that policymakers need to become informed about the science of learning. And like I mentioned, that IES practice guide, like those are evidence-based practices that should be used for teaching math. And yet we see programs in schools where they'll disparage practice. They'll call it drill and kill. They'll say that students should be discovering things for themselves instead of being explicitly taught by a teacher. These are new learners, and it goes against what the research says works. So the first thing I think that needs to happen is people need to get informed. And I don't think public funds should actually be spent on programs that aren't evidence-based. So that, to me, is just kind of a no-brainer. But that isn't what's happening, because I would say that the majority of programs are not evidence-based. They actually fly in the face of what the research actually says helps children learn math. So that's the first thing. And then I think that, and we're talking to parents, and I do think that it's important that parents get information consistently about how their child is doing in school, and meaningful information. So you have to test kids, you have to see how they're doing, to see if they're learning the things that they're supposed to be learning. We need to know that, because if kids fall behind, how can we help them if we don't know, right? And I think that the information needs to go to parents quite frequently about how their children are doing in math so that they can advocate for their kids. Parents are partners, and they're important partners in education. They care more about their kids than anybody, right? So they do need to be involved. And unfortunately, I think in some provinces, like in BC, where the report cards have just been, they have sort of these generic terms like proficient, or I can't even remember now, but it doesn't help parents and it doesn't help kids either. So we do need to be honest, and we need to be transparent about how kids are doing in school. And kids need a lot of practice. I can't emphasize that enough. Like, if there were one thing I would say to really, really change or really focus on, is just make sure kids need a lot of practice. It doesn't have to be boring. It doesn't have to be awful. And I think kids don't mind practice as much as we think they do. So those are a couple of the things. And then the other thing I usually mention is curriculum. You need to have a good math curriculum, right? It has to be set up in such a way that we're emphasizing those really important skills that help students get to a point where they can succeed in math later on.
You alluded to PISA, the Program for International Student Assessment, earlier. And I wonder, when you look at the results, the latest results, and you look at the countries doing really well with math outcomes, what stands out? Why is this happening in those countries?
Yeah, so that's an interesting question. And it can be hard to take something that's happening in another country and think about how we'd apply that here. And we have to be kind of careful about that. So, for example, a country that always does really well is Singapore, and the East Asian countries in general. So Shanghai, etc. But they also have a very different culture. So there's a lot of after school tutoring and things like that. Like a lot of those things, we wouldn't necessarily want to see that here. A lot of parents probably wouldn't go for that sort of thing. But there are things that we can take from how those countries teach math. I think in particular, like the Singapore curriculum, I've looked at it very closely. They have a really good curriculum. And they do emphasize the basic skills later on and then move on to problem solving. So it's a bottom up approach as opposed to a top down approach. I think a lot of times people want to take the problem solving piece from Singapore and Japan and do that, but ignore the fact that they already have a foundation in place. Because really, in order to solve complex problems, you have to have a lot of skills. You have to have a lot of tools in your toolbox to do that, right? So I think we can take some of those things and maybe use those things here. But I also think we have to be really careful, because you can't just translate things or move them out of context when you're dealing with different cultural aspects.
You talked earlier about some of the careers that we're looking at in the future, data science, STEM-focused careers, things that are going to be more and more prominent in the future that require math. So how dire is the situation in terms of how fast do we need to really address this to also then address future jobs that people might be interested in, but because of their math skills might not even be capable of even contemplating?
Sure. So it is really important. So it is really important to make sure that we have a lot of children who can excel in math. But I would say that one thing that always happens if children aren't getting the foundation they need in school, parents who can afford it and parents who are in the know, and they know that their children need to get these math skills, they will pay for it. They'll self-insure is what I always say. So they will make sure that their children learn the math that they need to learn so that they can enter those STEM careers, or at least have the hope of entering those STEM careers. So what you can end up getting is a two-tiered system, a system where parents who can afford it or who have the knowledge to help their kids will do that. They will make sure that their kids get that foundation, whereas the kids who don't have the means, whose parents don't have the means to help them, won't. So I think it's important for a couple of reasons. The first is what you said, that we do need these students to be able to enter those STEM careers, those technology careers, et cetera. But we have to make sure that we don't have an inequitable system, right? So that's why it's really important that kids get the instruction they need in school.
Now, in 2012, you and your husband, also a mathematician, started up a non-for-profit called Archimedes Math Schools. What was the impetus to start that up?
Okay, so my daughter was in elementary school at the time. And like I had said earlier, there was this new curriculum, which was quite radical. And we could see that kids weren't learning. We started off actually by having just a math club at our house. So we would go home, the kids would come over and we'd do math with them. But we felt bad because there were just so many parents would talk to us about this and what can we do, et cetera. And we felt bad about it. So and it wasn't just me and my husband. There were also 2 math professors at the other university in the province. And we got together and we just founded this nonprofit organization because we wanted to open it up to more kids to help them get a good foundation in math. So that's why we started it. And we just kept going since then. So it's actually fairly popular. So mostly we weren't able to take all the kids that want to join the program. We hire university students actually to teach the classes. So the math profs, we do this all as volunteer, right? So we're not taking any sort of salary for this, but we do, we charge the parents a tuition, a small amount. And we pay university students to actually teach the classes, but we designed all the lessons. And so it's quite a good program. And I think that the kids find it really useful.
How would you describe your approach in designing that curriculum and what has made Archimedes Math Schools successful to date?
Sure. So a lot of people would describe it as traditional, which probably isn't an inaccurate description. So we do concentrate on foundations. We give tests, regular tests, low stakes tests. We try to build confidence and just make sure that kids actually learn the math. It's an advanced curriculum in some sense, like it's advanced in comparison to the school curriculum, and that we sort of narrow in and focus on the most important topics and just try to do them really well. And so, for instance, we teach the kids algebra quite a lot earlier than in the school, and we teach fraction arithmetic a lot earlier than they do in the Manitoba curriculum because those are really important topics. So we also use a jump math, a combination of jump math and just worksheets and enrichment problems that we designed ourselves. And our kids also, they have the option of writing the Math League contest. So there's that enrichment piece too.
So when you think back to 2012 and you describe that your daughter was experiencing a change in curriculum, what was it about that curriculum change that sort of caught your attention, one? And what would you say to parents who don't have the level of expertise, the depth of expertise that you have as an educator and as a mathematician, to be able to address these issues that they might not even know exist?
Okay, so I'll tell you what we noticed. I mean, like I said, it was extreme. So the children were actually not taught the standard algorithms. So what I mean by that is addition with a carry, subtraction with a borrow, the regular multiplication and long division that you learned as a kid. In fact, they weren't even allowed to use it at school. So my daughter, who was in grade 3, she knew how to use the standard algorithms because we taught her at home because they're much easier to use. And she would just write underneath her desk. She wasn't allowed, it was just bizarre. So, and then they weren't memorizing times tables, which is just I mean, that's really going to hold you back if you don't know your times tables. So those were the main things that we noticed, but it was a lot more than that. It just was a complete disaster. So for parents that don't have the expertise, well, the good news is we're just talking about basic arithmetic. So you can get worksheets online, get the kids to practice them, help them with it, definitely get them working on their times tables, those things, and fractions, like just concentrating on those basics that most parents likely know. I think they can help their kids that way. Even Khan Academy, like you can look on Khan Academy and it would even help teach those things, right?
So we're talking about starting ideally at what age then?
Oh, wow. Okay, so probably grade 2. I'd say grade 2, grade 3, definitely. I mean, it starts quite early, even with just knowing your addition and subtraction facts, right? Like that should be done pretty early on. If that's not happening, if the child is falling behind, I'd get on that fast. Just because it snowballs. It doesn't, that's the thing with math that a lot of people, maybe they don't realize that it's really, really cumulative. And so things can snowball quite quickly.
So along those lines, like one of the things I've heard about this debate with respect to how math is taught is about who is teaching it. There's a school of thought that suggests you really need math experts, mathematicians, people who are passionate about math, teaching math. You know, every educator has a different area of expertise, something that they're better at teaching than others, as opposed to a generalist teaching math. What's your assessment of that?
Sure. And by the way, that's something I've thought a lot about. I don't always talk about that anymore, but I've thought a lot about it. So first of all, we don't need mathematicians teaching math to kids necessarily. Like I'm a mathematician and I'm fairly good at teaching, I would say, but not every mathematician is good at teaching, but also not every person who's good at teaching is good at teaching math. That's the other thing. So you have to be a bit careful. So I always say, so first of all, you can't teach what you don't know. That's basic common sense. I don't have to prove that to anybody. I think that's clear. You can't teach what you don't know. So there's that. But teachers also, they should know beyond what it is that they're required to teach, because how do they know what's important? Like, how do they know what they're preparing students for? Okay. So there's that. And then it is true that I think particularly in elementary education, there are a lot of students in that program that struggle with math themselves. I know this because I teach at a university and we have a lot of education students in the university. And that is troubling. And I've always been quite troubled by this. So I think, and some people have called for math specialists in K to 8. I have called for that in the past. I don't know where I'm at with that because I think that like it's something that I've tried to advocate for in the past. And I think politically, I think that's a hard sell. So it would be hard to get there. But I think certainly we can ensure that pre-service teachers get a better education in math so that they're better prepared to teach the subjects that they need to teach. But it's not just that, they need good resources. And so a lot of times I see in schools that they don't have resources at all, and they're having to pull stuff off the internet, or worse, they have bad resources. So they're supposed to teach things through open-ended problems. You know, they're not advised to teach in a systematic way. Well, so now you've got an ineffective teaching method and a teacher who maybe struggles with the math. It's a witch's brew, as I always say. So I think this is a really important issue. Now, some people will say that the reason for generalists in schools in K to 8 is that they're with the children for each subject all day, and that gives them a better opportunity to bond with the children. Okay. So, and I don't really weigh in on that. I'm not really sure. I don't teach in a school, right? So those types of things I try not to say too much about because I don't know, but I do know about teaching math, and I do know that you need to know math to be able to teach it properly. So it's something we need to work on. It's something universities need to work on. We have developed courses here for K-8 teachers, which I think are helpful. But I mean, when students come in and their skills are really, really weak, it can still be quite difficult. But bottom line, we have to give teachers good resources. So if you're not giving good resources, it's not going to help anybody. It doesn't help the kids, and it doesn't help the teacher, right? So yeah, those are some of the things I would say about that.
Now, speaking of resources, you alluded to tutoring in some of the countries that we talked about earlier. At what point should a parent consider a tutor? Like, are there telltale signs? You know, you've tried the basic math support at home, you've downloaded off the internet, you've done all these things. At what point do you say to yourself, I'm not satisfied with the support I'm providing at home or what's going on in the classroom? We need to go to look for a tutor. And how do you determine the best fit of a tutor for your child?
Yeah, that's a good question. So a lot of parents can't afford tutors. So we're talking about parents that are in a position where they could get tutors, I guess. And wow, I mean, I would say, so, okay, I would say by grade 6. I think grade 6 is kind of a pivotal grade. That's the point where, you know, soon you're going to be learning fractions, or hopefully you've already learned fractions, depending what province you live in, not in mine, but you should. In grade 5, 6, you really should be learning how to do fraction arithmetic. And I'd probably, I would suggest, say, Kumon. I've heard a lot of good things about Kumon. If you can find a nonprofit in your community, like our nonprofit, and there are other nonprofits that do math tutoring in Manitoba, and they're great too. So you could try that. But a lot of people really like Kumon, so that might be a good choice, or Sylvan, something like that. Those are pretty reputable programs. For enrichment, a lot of people like Spirit of Math. So that's one that I also will recommend. But yeah, I'd look around grade 6, and then you don't want to leave it till high school in a way. Like, it's possible that if you just get some help in around grade 6, 7, 8, that maybe that would set the child up so that they can succeed in 9 to 12.
So what would you say to a parent then who maybe has missed the boat? That student is now past the ages that you're talking about, past grade 6, in order for them to still try to find a way to succeed in math?
Yeah, so you have to take it back to the place where the student's behind. So it's going to be impossible if you're now at a point where you're trying to, say, solve algebra problems and you don't know your times tables. And say you're trying to factor and you don't know off the top of your head that 5 times 4 is 20 or something like that, right? It's going to be really difficult. So the key is to take it back to the point where the student is really struggling. So if you do go to a tutor and it's a little later, I think I would ask to make sure that they do an assessment of the child to see where it is that foundation's missing, and to make sure that they get caught up in that foundation. But I mean, it's never really too late, right? Like, it better late than never makes sense in this case. So I think even if you're at the point where now you're in grade 10, I think it still makes sense to try to do something about it instead of just throwing your hands up in the air.
Lots of great food for thought. Dr. Anna Stokke, Professor of Mathematics at the University of Winnipeg, thank you so much for taking the time to share your insight with us today.
Oh, it was my absolute pleasure. Thank you so much for having me.